Alright, hello everyone. I hope everyone had a great Memorial Day weekend and you were able to take some time for yourself, get away from the computer, decompress a little bit, and come back to the course now and try and knock out these projects. Due date is the 31st, so I hope everyone stays on track. This has been a very challenging section. If you are unfamiliar with AWS, it's a lot of different technologies to take in, as well as a lot of unusual syntax. That's what I kind of found was some of the hardest part, was just the overwhelming amount of parameters it requires and just getting familiar with the AWS platform itself. Anyways, we're going to go ahead and jump in. It's going to be a little bit more Redshift today. We're going to be creating some tables, programmatically creating IAM roles, as well as configuring our connections to EC2, Redshift, and yeah, so let's go ahead and dive in here. As usual, we're going to be importing Boto3, which is our Python client, which can interact with AWS on our behalf. We're going to be importing pandas as PD, and then we're also going to be importing JSON. So next, we're going to import our config parser, which is going to access our config file that we've created in this root directory. So first we're going to say config equals config parser dot config parser. We're going to call that method, as you can see here, notified by the parentheses. Then we say config dot read file open config dot config. Now within the config file we have already defined our key. So we are going to say key equals config.get. AWS is the header, and key is the key or ID that we are looking for, and it will return the value that we have assigned in the config file. Next, what it expects is our secret, which is secret equals config.get AWS and secret. Now we're going to get into the data warehouse parameters that we need to provide. So we provide a variable DWH cluster type equals config.get. We provide DWH, which is our header name, and then DWH cluster type, which is the ID or key that we are accessing. Alright, so the rest of these are actually, it's going to be the same process. We're going to be accessing our different parameters that are under the DWH header, such as num nodes, node type, our cluster identifier, DWH DB, DWH DB user, DWH DB password, and the DWH port. Finally, we have to provide our IAM role name, which is also stored in the config file. Now what we're doing here is we're creating a data frame. We're going to create two columns, one being parameter and the second being value, just to give ourselves a better view of all the parameters that we have provided. As you can see here, we have our param column and we have our value column. So we have created a multi-node cluster type with the 4 as the number of nodes. We created a DC2 large. Our cluster identifier is data warehouse cluster. The database that we are accessing is DWH for data warehouse. And the DB user is DWH user. We have our generic password here, and the generic port or default port provided by Amazon is 5439. This may be different on your system if by chance you are already using 5439 for something else. And finally we have the DWH IAM role name. In my case it's DWH role. So now we're going to connect to EC2, S3, IAM, and Redshift using Boto3.resource module. So first we have our variable name EC2 equals Boto3.resource. we provide the service which we are accessing, which is in our case is EC2. We must provide the region name, and then we must provide the AWS access key ID and the secret access key, which is calling the variables that we assigned earlier from our config file up there. And we need to repeat that same process, one for S3. Once again, we provide the region name, our access key ID, our secret access key. We do the same for IAM, following the same steps. And then we finally provide one for Redshift. So we're going to go ahead and just work with a sample bucket here, which is our sample DB bucket equals s3.bucket. We provide the name of the bucket, which is AWS sampled bus west 2. And then we have our simple for loop here to go ahead and iterate over the objects that are contained within the sample DB, providing the prefix equal to SSBGZ. So as you can see here, all that is returned are the objects which contain the prefix SSBGZ, as you can see here. Okay, so next we're going to create our IAM role programmatically. But a little background on the IAM role. So an IAM role is an IAM identity that you can create in your account that has specific permissions. An IAM role is similar to an IAM user in that it is an AWS identity with permission policies that determine what the identity can and cannot do in AWS. However, instead of being uniquely associated with one person, a role is intended to be assumable by anyone who needs it. Also, a role does not have standard long-term credentials, such as a password or access keys associated with it. Instead, when you assume a role, it provides you with temporary security credentials for your role session. You can use roles to delegate access to users, applications, or services that you don't normally have access to your AWS resources. For example, you may want to grant users in your AWS account access to resources they don't usually have. Or grant users in one AWS account access to resources in another account. Or you might want to allow mobile app to use AWS resources, but don't want to embed AWS keys within the app, where they can be difficult to rotate and where users can potentially extract them. Sometimes you want to give AWS access to users who already have identities defined outside of AWS, such as in your corporate directory. Or you might want to grant access to your account to third parties so that they can perform an audit on your resources. For these scenarios, you can delegate access to AWS resources using an IAM role. Okay, so in order to create an IAM role programmatically here, first we're going to import from bodocore.exceptions import client error. Then within a try except, we are going to try to print creating a new IAM role. Then we provide the DWH role equals IAM.create role. We provide the path. We say our role name is equal to DWH IAM role name, which is, once again, using the variable that we first defined up here within our config file. We provide a description, which is just a simple explanation of what this IAM role is for. Then we say assume role policy document equals json.dumps, and then we provide a dictionary here including statement with a list as the value, which is containing a dictionary that has the action, the effect, and the principle. Next we have a version, which we provide as 2012-1017. Finally we have our accept, which will catch any exceptions that are thrown, and then we print that exception. Next, we just have a print statement here, and then we say im.attach role policy, role name equals DWH, im role name, and then we provide our policy ARN. Finally, we have role ARN equals im.getRole, role name equals DWH, im, role name, and then we call the role and the ARN. Finally, we print the role ARN. And as you can see here, it says creating a new im role. In my case, I already had created this user before, so it did throw an error. And it's just telling me that that user already exists. Finally, what's printed out is the role ARN associated with our new im role. Alright, so next we're going to go ahead and create a cluster. So we're going to try. We're going to say response equals Redshift dot create cluster. Then we provide the cluster type, the node type, the number of nodes, which we must first convert to an int. Here we have our identifiers and credentials, which are the DB name, the cluster identifier, the master username, and the master user password. Then we provide our roles for S3 access, which is the im role that we had just created. Once again, we have our accept, which will catch any errors if we encounter any during this statement. Now we just have a helper function here that will kind of pretty up what is returned while we are creating this cluster, and it will give us an update on whether the cluster is currently available, as you can see here. But you'll have to give it about 5 or 10 minutes to let AWS actually initialize the cluster for you. And we can also see that we have all this other useful information. We have our cluster identifier now. We have the node type, the cluster status, master username, DB name, our endpoint, which also shows the port that we're on, and the VPC ID, as you can see here, and the number of nodes. So if we want to see our DWH endpoint, we would just simply call myClusterProps endpoint, and then we access the address within that. And if we want to see our role ARN, we say myClusterProps, we access im roles, the first index of that, and then we print out the value associated with the im role ARN. As you can see here, now we have our endpoint, and we have our role ARN. So a little bit about VPC and subnet basics. A virtual private cloud, VPC, is a virtual network dedicated to your AWS account. It is logically isolated from other virtual networks in the AWS cloud. You can launch your AWS resources, such as Amazon EC2 instances, into your VPC. When you create a VPC, you must specify a range of IPv4 addresses for the VPC in the form of a classless interdomain routing, CIDR. For example, 10.0.0.0/16, this is the primary classless interdomain routing block for your VPC. For more information about CIDR notation, CRFC 4632. Alright, so now we're just going to go ahead, we're going to use this VPC, and we're just going to be able to provide the IP that we're currently working on, and then we're going to give it the IP protocol. So we say try VPC equals EC2.VPC. The ID is equal to myClusterProps VPC ID. Default SG equals list VPC.security_groups all. And then we want to access the very first index of that, what is returned from that .all. We print the default SG, and then we call the .authorized ingress property. We provide the group name equals default SG.group name. The CIDR IP. In production use, you will not want to use this default IP address, as it basically allows anyone to access it. But for this demonstration, it will work just fine. And we want to say our IP protocol equals TCP. So then we want to say it's from port, which is our DWH port, to port, DWH port. And once again, we must convert those to ints, because otherwise they would be strings and it would be invalid. And in my case, I've already run this so that we didn't have to wait for the cluster creation, but you can see that we do get our printout saying that mine was already created. So now we're going to go into start to create our databases. And here we go. We have our load extension of SQL. We have our connect string. And we're going to go ahead and connect to PostgreSQL. And then we have to provide our DWH DB user, the DWH DB password, DWH endpoint, DWH port, and the DWH DB. And as you can see, we're now connected. And I'm hoping that I didn't delete my cluster by running this. This should have been done at the end. Let's see here. Uh-oh, it looks like I deleted it. So we're going to go up here and we are going to go ahead and rerun the cluster creation. Alright, so while that loads, let's see what we can get into down here. So yes, I should have put this at the bottom of the presentation so that I can go ahead and delete that cluster so as to not incur any unnecessary charges. And I will put that right above our IAM detach role. Okay. Excuse me. Alright guys, sorry about that. While this loads, I'm actually going to just take a minute here. If you feel free, go grab yourself a coffee, and I will be back in just a moment. Alright, so let's see where we're at. We're going to use our pretty Redshift props to try and print this out. As you can see, we are still creating our cluster. This will just take a few moments. In the meantime, we'll take a look at the AWS Educate website here. So if you haven't already joined this, you will find tons of resources. They have pathways where you can learn about all kinds of different AWS services. Let's see if I can go ahead and log in here. Alright, so I had started the Cloud Support Engineer, but let's see if we can go back and we'll see all of the different pathways that they have. So they have Cloud Support Engineer, they have a Data Scientist, so you can actually run machine learning models on it. Machine Learning Scientist. As you can see, they have a lot of different stuff, so I highly recommend that you guys take full advantage of the AWS Educate promotion that you were able to get through taking this course. You never know where these skills will come into hand, and it will just, the more you know, the better. So now let's go ahead here and check out our cluster, still creating. So I highly recommend that you guys keep these functions, like keep a blueprint of these, if you will, saved in somewhere in your local files, so that you don't have to constantly, you don't actually have to memorize all of these different parameters that we're constantly having to provide. It's good just to have a blueprint somewhere that you can just copy paste, provide the appropriate config file that you're going to need. Just really streamlines the process and makes it a lot easier to access your Redshift clusters. Alright, as you can see now, we now have our cluster status available. Sorry about that delay. So we're going to go ahead, just run these few cells here. Okay. Alright, so we are now accessing our clusters. We see we have our cluster identifier and all of the appropriate information. So now we're going to get into accessing the S3 bucket. So first we're going to import time, and then we're going to import matplotlib so that we can get a visualization of the time differences of our various approaches to loading data. So we're going to be accessing our sample DB bucket, which in our case is Udacity Labs, and we're going to filter it based on the prefix of tickets. So as you can see here, we have our tickets prefix and then all of the associated files that are within it. Now just a quick overview of the different data types available in Redshift. We have small int, which is assigned 2-byte integer. We have integer, int or int4 is assigned 4-byte integer. Big int, which is assigned 8-byte integer. Decimal, numeric, exact numeric of selectable precision. And then we have real float 4, which is a single precision floating point number. Double precision, float 8, is a double precision floating point number. Boolean, which is a logical Boolean, which is true or false. Char, or character. Nchar and bpchar are fixed length character string. Varchar, character varying, and varchar, and it's text with a variable length character string with a user-defined limit. Then we have 3 different options for dates and times. So we have date, which is a calendar date in the form of year, month, and day. Then we have a timestamp without time zone, and that's the date and time without a time zone. And timestamp TZ, which is a time zone included in our datetime object. So here we're going to go ahead and create a table called sporting event ticket. We're going to provide an ID, which is a double precision The default is next val, which is similar to serial, which we were using in Postgres. And then we're going to say sporting event ticket sequence, not null. Our next column will be sporting event ID, which is a double precision, not null. Sport location ID. Seat level, we're going to say it's numeric with 0 float precision. And that is also not null. Seat section, we're going to have it as character varying with a limit of 15 characters. That's also not null. Our seat row, which is character varying because we're most likely going to want both letters and numbers for our seat rows. Then we have seat, which is character varying with a limit of 10. Then we're going to have a ticket holder ID, which is double precision. Ticket price is numeric. And it's going to have 2 float precision, as you can see here, with a limit of 8 values. Alright, so when we run that, we can see that we created our sporting event ticket table successfully. Now we are going to copy our sporting event ticket from the S3 bucket. We provide our credentials. We use a placeholder here, which we are then providing the DWH role arm after our string. It's also important to note that we are compressing the information using gzip, which will speed up the process, providing a delimiter of a semicolon, comp update off, and then we're also finally providing the region, which is US West 2. We can see that that took about 37.5 seconds. So now we're going to be creating a sporting event ticket full table. Run that. It's very similar to what we already did. We have our ID, which is using the double precision, default next val. We have our sporting event ID, sport location ID, seat level, seat section, seat row, seat, ticket holder ID, and the ticket price. Alright, so now when we time that, once again, we are going to optimize it by using it as a gzip compression, providing a delimiter, comp update off, and the region of US West 2. Finally providing our DWH role arm. So as you can see, the time on that one was only 23.7 seconds. So now we're going to import OS, which connects to our operating system through Python. We provide our connection string to our PostgreSQL, and we're providing the DWH DB user, DWH DB password, the DWH endpoint, DWH port, and DWH DB. And when we run that, we are now connected to our data warehouse, and we are going to go ahead and recreate this table here. It's a lot of different SQL commands, but we're going to go ahead and break this down a little bit. So we're going to have our SQL client here. We're going to say create schema if not exist, and it's going to be called dist. Set search path to dist. And in case we've already created them, we provide our drop tables if already exists. And first we have a parts table. We have multiple category or multiple columns within here. Part key, name, MFGR, category, brand 1, color, type, size, and container. Next we're going to have a supplier table. That's going to include information about our suppliers, such as the name, address, city, region, phone, and so on. Then we have a customer table. Finally, we have our date table. And then we have our line order table. Line order in this case looks like it does contain the majority of the analytical information, such as the quantity, extended price, order total price, discounts, revenues, and so on. So you could think of this as our fact table. So when I run that, you can see we are successfully creating all of the various tables that were defined. Alright, so now we're going to have a function here called load tables, which takes the schema, which we defined earlier up here, called dist. And we're going to have an empty list there that will contain our load times. And as you can see, we have SQL set schema equals set search path 2, and then we're going to format it using the schema argument that was provided in the function. So now we say for table in tables, we're going to do a copy from our S3 bucket here. We provide the credentials, the gzip compression, and the region which it is located. And we're going to provide our table, and DWH role arm for these placeholders here. Now we're just doing some prints to give some returns from when we call the function. It will return this, kind of letting us know how the process is going. And then we have our time here, so we're going to initialize the current time at the very start of it. And then we do our SQL copy, and then we do a time minus the time that it was started. And then finally we append that to our load times empty list. So let's see what happens when we run that. Alright, so now we're going to go ahead and use our load tables function. Okay, so the list of the tables to be loaded are customer, DW date, supplier, part, and line order. And here we have insertion twice for each schema. Each can take more than 10 minutes. Okay, so we're now running that. You can see here that it's telling me that the schema node_dist does not exist. So we did not have a node distributed table defined. We are only working with the distributed version right now. Well, let's see where I was supposed to create that node_dist. Okay, so rather than keep you guys waiting here, as you can see, this can take more than 10 minutes for each one. But we have gone ahead and shown you the process of creating your own tables and copying tables from buckets. If we use these matplotlib functions here, it will show you the difference between the distributed copy as well as the load time of the non-distributed. So interestingly, the supplier table actually was a little bit faster when I ran this using the non-distributed, but for the most part we can see here customer, DWH date, as well as the parts table all were faster when we used a distributed method. So it's important to use those distributed methods when copying your tables in order to optimize performance. So most importantly, as you can see, I messed that up earlier. We want to make sure that we delete our cluster as to not incur any unnecessary charges. And finally, we want to actually detach the role that I had created just for this example. Anyways, I hope that this was insightful for you guys and you're coming along with your projects. Feel free to reach out if you have any questions, and I'll be sure to respond as soon as possible. I hope you guys had a great Memorial Day weekend, and I hope to hear from you soon. Take care.